equals to 3. So here we will write x is less than 3 and x is greater than 3. Clear? Now we want to prove that the function is continuous but not differentiable. For left hand limit, f of x, limit x tends to 3 negative, limit x tends to 3 negative, modulus of x minus 3. When x tends to 3 negative, then the function is negative because x is less than 3. Now put the limit h tends to 0. When the function has negative limit, then instead of x we will put 3 minus h. If positive, then we will put 3 plus h. Because here we have the term 3, therefore we are putting 3 minus h. If there is 0, then 0 minus h. So on 1, then 1 minus h. Now negative 3 it will cancel. Limit h tends to 0, minus minus plus h. So the answer is 0 for the left hand limit. Now for the right hand limit, limit x tends to 3 positive f of x. That is, limit x tends to 3 positive modulus of x minus 3. Limit x tends to 3 positive, here this is positive. Now put limit h tends to 0, x as 3 plus h minus 3. It will get cancelled. Limit h tends to 0, h. Now left hand limit is equals to right hand limit. Therefore the function is continuous. Therefore the function is continuous. Now we want to prove that function is continuous at x is equals to 3 but not differentiable. Now we want to prove it for differentiability. Now we will have to find left hand derivative and right hand derivative. Left hand derivative, limit x tends to 3 negative, f of x minus f of 3 upon x minus 3. When x tends to 3 negative, then the value of this is minus x minus 3. F of 3, put f of x is this, put f of 3, instead of x put the value 3 here. So 3 minus 3 is 0 and x minus 3. So limit x tends to 3 negative, it will get cancelled, so we get minus 1. So the answer is minus 1. Now for the right hand limit, right hand derivative, limit x tends to 3 positive, f of x minus f of 3, x minus 3. Now when the right hand limit, function has positive value x minus 3, f of 3 is 0. Since f of x is equals to modulus of x minus 3, so f of 3 is 3 minus 3, 0. Now x minus 3, it will get cancelled, so we get 1. Now left hand derivative is minus 1 and right hand derivative is plus 1. So left hand derivative is not equals to right hand derivative. Therefore the function is not differentiable at x is equals to 3. Not differentiable at x is equals to 3. सिक्सटीन्थ का ही और पार्ट है हमारे पास. राइट डाउन द स्टेटमेंट ऑफ दैट. इफ x is equals to a sin t, y is equals to a cos of t plus log tan t by 2, then find d square y upon dx square. First, this is the function with respect to t. So first find dx by dt. Differentiate with respect to t. Derivative of sine is cos. by 2. Derivative of tan is sec square x, but x here is t by 2. So again we have to take the derivative of that. Derivative of t with respect to t is 1 and 1 upon 2. Clear? Now instead of this we can write it as minus sin t. Tan is sin upon cos. So cos sin. Sec square is 1 upon cos square. T by 2, 1 by 2. 1 power of cos will cancel. Here we have left with 2 sin t by 2 cos t by 2. 2 sin theta plus cos theta. Sin 2 theta is multiply. So sin 2 theta is 2 sin theta cos theta. Here the angle is half. So it will become sin t. We can write it as by taking LCM sin square t plus 1 upon sin t. 1 minus sin square is cos square upon sin t. Now this is dy upon dt. We want to find dy upon dx. dy upon dt into dt upon dx. dy upon dt is this. Now 1 upon dx upon dt is a cos t. A cos t will cancel. Cos upon sin is cot. So cot of t. Now we want to find the second derivative. D square y upon dx square. Derivative of cot is minus cosec square t. Derivative of t is dt upon dx. So minus cosec square t 1 upon dx by dt. Cosec is 1 upon sin square. So a cos t. Now the next one is evaluate integral of sin x minus a upon sin x plus a dx. We can write this integral as in numerator add and subtract a sin x plus a, that is sin x plus a minus 2a. Here we will apply the formula that this is one term sin of a minus b, that is equals to sin a cos b minus cos a sin b. Now apply this formula sin a cos b minus cos of a sin of b. Separate the terms. Sin x plus a sin x plus a dx. Here sin will get cancelled. Cos 2a is constant. Integral of 1 with respect to dx is x. Sin 2a is constant. Cos upon sin is cot. X plus a dx. Now what is the integral of cot is log sin x. So x cos 2a minus log sin x plus a sin 2a plus c. इसी का और पार्ट है। Evaluate integral of 5x minus 2 upon 1 plus 2x plus 3x square dx. In this question, first complete the derivative of this in the numerator. If we see, the derivative of this term is 6x plus 2. Derivative of 1 is 0, 2x is 2, 3x square is 6x plus 2. Now we want this term in the numerator. So first take 5 common. X minus 2 by 5. 6x, so multiply it by 6. 6 into 2, 12. 6x plus 2, so add and subtract 2 in the numerator. 6x plus 2 minus 12 by 5 minus 2. 5 into 2 is 10. So that is minus 22 by 5 upon 3x square plus 2x plus 1. Now separate the terms. 5 by 6. 6x plus 2. 3x square plus 2x plus 1 dx minus 5 by 6, 22 by 5 dx upon 3x square plus 2x plus 1. In this integral, we have to complete the whole square, and this is the derivative of the term in denominator is in the numerator. So this is of the type integral of f dash x upon f of x. That is equals to log of f of x. So we can write it as 5 by 6 log of 3x square plus 2x plus 1. Now we have to solve this. Minus 11 by 3. For completing the square, first coefficient of x square should be unity. So take 3 common. We are left with x square plus 2 by 3x plus 1. Now add and subtract half coefficient of x whole square. 2 will get cancelled. 1 by 3 square, that is 1 by 9. Now we will have to add and subtract 1 by 9. Now in the next step, 5 by 6 log of 3x square plus 2x plus 1 minus 11 by 9 dx upon x प्लस 1 by 3 होल स्क्वायर. एक बार ओपन करके आप देख सकते हो a स्क्वायर प्लस b स्क्वायर प्लस 2ab. 9 minus 1, 8 by 9. We can write 8 as 2 root 2, 9 as 3 square. It is clear? 2 root 2 square. Now in the next step we will apply the formula integral of 1 upon x square plus a square. Here when we take 3 common, 1 by 3 is here. So taking LCM, 3 minus 1, 2 by 3, root 2 by 3. Integral of 1 upon x square plus a square. 5 by 6 log of 3x square plus 2x plus 1 minus 11 by 9, 1 upon a. A is root 2 by 3. So 3 root 2. 1 upon a, tan inverse x upon a. X upon a plus constant of integration. So 5 by 6 log of 3x square plus 2x plus 1 minus 11 3 root 2 tan inverse 3x plus 1 upon root 2 plus c. Now the next one is question number 18. Evaluate integral of plus 4 x square plus 9 dx. This is the portion of partial fraction. Now the terms which is in the denominator is a quadratic which cannot be factorized further. So what we do, put x square upon x square plus 4 x square plus 9 as ax plus b upon first factor plus cx plus d upon second factor. Now take the LCM. Ax plus b into x square plus 9 cx plus d into x square plus 4. Denominator by taking LCM will get cancelled on both sides. So x square is equals to ax cube plus 9ax plus bx square plus 9b plus cx cube 4cx plus dx square plus 4d. Now equating like coefficient terms. Equating like coefficient terms. By equating like coefficient terms, first equate the coefficient with x cube. X cube के coefficient की equate करी, then a plus c. Here we did not have any term with x cube, so we can write 0x cube, so 0. Now equate the coefficient of x square. X square is b and d, and here coefficient of x square is 1. Now after that coefficient of x, 9a plus 4c, but on left hand side there is no term with coefficient of x, and constant term. After equating constant term 9b plus 4d, left hand side there is no term with constant term. So from here we get c as minus a. Put the value of c as minus a. 5a is 0, so a is 0. Put the value of a here, so c is also 0. From here multiply this equation by 4. So we get 4b plus 4d is equals to 1. Subtract 9 minus 4, 5 minus 1. So we get the value of b as minus 1 by 5. Put this value of b here, minus 1 by 5 plus d. So d is 1 plus 1 by 5, that is 6 by 5. Note up to here. By multiplying it by 4, here is 4, so minus 4 by 5. 5 plus 4 is 9. So 9 by 5 here. Now in the next step, put this value. Let this integral as I is equals to ax plus b. A is 0. 0x plus b is minus 4 by 5 upon x square. We can write 4 as 2 square. Plus cx plus d. C is 0. 0 into x. 0 plus d. 9 as 3 square. Integral of 1 upon x square plus a square, 1 upon a, tan inverse x upon a. Same here, 1 upon a, tan inverse x upon a plus constant of integration. So minus 2 by 5, tan inverse x by 2 plus 3 by 5, tan inverse x by 3 plus c. Now the next one is question number 19. Evaluate integral 0 to 4 modulus of x plus modulus of x minus 2 plus modulus of x minus 4 dx. We have to solve this integral. Now we know that modulus of x minus x when x is less than 0, x when x is greater than equals to 0. Now x minus 2, when we put x minus 2 is equals to 0, then x has value 2. So it will negative when x is less than 2 and positive when x is greater than equal to 2. Similarly for x minus 4, negative when x is less than 4 and positive when x is greater than or equal to 4. Now the limit goes from 0 to 4. This is point, it has point 0, so we can write it as 0 to 4 modulus of x. Here when limit goes from 0 to 4, x minus 2 dx. So here when we put x minus 2 is equals to 0, we have point x is equals to 2. So the first limit will go from 0 to 2, then from 2 to 4. Is this step clear to everyone? Now next is x is 4, so the 0 to 4, x minus 4 dx. Now 0 to 4, 4 से छोटा, 0 से ग्रेटर जा रही है टर्म बिकॉज लोअर लिमिट इज 0. 0 से टर्म बड़ी जा रही है तो मॉडुलस ऑफ x की हमारे पास क्या वैल्यू है? x. नाउ 0 to 2, 0 से तो बड़ी है टर्म लेकिन 2 से छोटी है. अगर 2 से छोटी है तो हमारे पास ये वैल्यू है 2 minus x. So plus 2 minus x dx, limit goes from 0 to 2. Now 2 से बड़ी है और 4 से छोटी है, x is greater than 2, then this modulus has value x minus 2. Now next term is 0 to 4, 0 से बड़ी but 4 से छोटी, 4 से छोटी